All right, let's get started. So first of all, thanks to everyone for coming, and thanks to JP, Dave Lee, and the whole crew at Lyft for organizing this event, and of course, thanks to Lyft for hosting us here today. So yeah, like JP said, my name's Inderji. Up till recently, I used to work at Facebook. I was an infrastructure engineer on the iOS app. And one of my recent side projects or weekend projects was building a view debugger using SceneKit. And there's a bunch of stuff that I learned throughout the process, and it got more of like a response than I anticipated, so which is why I got convinced to come here and do this talk about it. So getting started. So the agenda for this talk is I'm going to be talking about the problem that I was trying to solve with this, and kind of like the story of how it went about. Some discussion about using SceneKit to build 3D UIs in your iOS apps. And then some gotchas that I ran into when doing view snapshotting on iOS, which is like a pretty critical part of building a thing like this. And then finally, some discussion about building Swift frameworks that work not only for Swift apps, but also Objective-C apps. So I think a lot of people in this room are pretty familiar with the product called Reveal. It's a really, really cool visual debugging tool for iOS. So it supports, this 3D like exploded view of the view hierarchy, navigating through your hierarchy, inspecting individual views, changing layouts. There's just a ton of functionality built into this, and it's really useful for anyone who's building an iOS app. So shortly after Reveal was originally built and released, Apple followed up with their own implementation in Xcode. So this is the Xcode view debugger. It looks pretty similar. They still have the same kind of 3D exploded view and the hierarchy. It doesn't have as many like introspection capabilities as Reveal, but it's pretty good for most common use cases. So the common theme with both of these earlier apps is that they're super powerful and they're great to use on a computer, but they require you to be tethered to a computer. So what happens if you you have a dog fooding build of the app on a phone or an iPad and you run into a UI bug or a layout bug of some kind and you want to figure out or try and guess what's going on. And so if you don't have a computer nearby, you can't really use either one of these tools to debug. So what if you could debug it on device? So the original inspiration for this tool came from a friend of mine, Kyle Van Essen. So he's an engineering manager at Square, and he works on their point of sale app. And so one day I randomly saw this tweet in my feed where he posted this picture of a view debugger that was embedded inside their iPad app. And I thought this was like really, really cool. So I was looking for a weekend project to do. I was looking for something to do on the side. So I decided to go and try and build it. And again, like Kyle's reiterating the usefulness. Tony questioned him. Funnily enough, Tony is an engineer on Reveal, so he's very familiar with the space. And like I said earlier, Kyle was talking about how it's like really useful to find a bug. If you find a bug on device and you want to debug it. So I decided to go for it. So over a weekend, I kind of built like the initial prototype of the 3D snapshot view. So there wasn't many other features. You could kind of like visualize your view hierarchy here, rotate it, and there wasn't much else. There wasn't no view introspection. There was no like tree view or anything like that. But I kind of posted about it, and I got enough interest that I decided to spend a few more weeks polishing it and turning it into an actual open source project. So what I built looks like this. This is the implementation inside an iPad app. So I used this open source audio synthesizer app called AudioKit Synth 1 for this demo. So what this is, essentially is I integrated the library into the app and I snapshotted like the main view of it. And you can see you can like go through, look at the various views in the app. You can focus on sub-hierarchies. You can look at all the names of the classes of the views that are being used to construct this UI. And so this is kind of where I stopped. So I built the 3D snapshot view, built the hierarchy view, and then open sourced it. So next up, I want to talk a bit about the process of how I came to build this and some of the technical details of the process involved here. So when you're looking at building anything in 3D, your initial inclination is you might want to use OpenGL. So OpenGL, it's good for cross-platform stuff. It's available on iOS and Android, although deprecated now on iOS. They're pushing everyone towards Metal. And then you have Metal, which is like Apple's proprietary high-performance graphics API for doing all kinds of GPU stuff, not just rendering computer graphics, but also doing like convolutional neural nets and just a really flexible API directly on top of the GPU hardware. So these two are great options for building complex products, but they have a really steep learning curve. So to use one of these, you have to have some knowledge of linear algebra, you have to know shader programming, and some fundamental 3D graphics programming concepts. And if I'm just trying to inject a bit of 3D into my otherwise pretty standard traditional iOS app, this stuff is pretty overkill. And there's a steep learning curve involved. So I didn't really want to go and start using this. So the next thing I thought about was, what if I use SceneKit? So SceneKit is a higher level object-oriented API on top of Metal that Apple introduced a while ago. So I think it's been since like iOS 8 or macOS 10.8 that this has been available. And so it gives you like an easier way to build common things, build 3D scenes in iOS and macOS. So in getting started with SceneKit, I wanted to understand if you could just use SceneKit. Like if you don't know anything about 3D graphics, no background in it, and all you've been doing is building iOS apps with UIKit and regular frameworks, like if you could just start using SceneKit and building 3D stuff with it. And as I came to understand, the answer is yes. So I spent a couple hours with it, got something up and running. I put an asterisk next to the anything here because like you have to know some things. Like there's a few additional pieces of knowledge you have to build on top of your UIKit stuff to get this to work. But overall, like if you use UIKit, you can jump into this and start using it. So this next part's probably not going to be super interesting for anyone who's ever used SceneKit, but I figured it would be useful to go over a primer of SceneKit and kind of the parts of the API that were useful when building this particular library. So SceneKit is essentially, it lets you render 3D scenes that are represented using a graph of nodes. So these nodes come in various types. So there's the geometry nodes, which represent 3D shapes in a 3D coordinate space. There's the lighting nodes where you can add point sources of light. You can control how the scene changes as you move the camera around, like various reflective properties and stuff. And you can build complex lighting models in SceneKit. And then there's the camera nodes that control like the point of view at which you're looking at the scene. So if you want to move around the camera, or you want the camera to automatically follow some object that's moving through a scene, you would use a camera node for that. So diving into like the specific types of nodes. The geometries are, you can build them in a number of ways. So you could use like a 3D authoring tool like Maya or something and build a model there, export it, and then use it in your app. You could use some of the built-in geometries for different 3D shapes. So they predefine cubes, cylinders, spheres, pyramids, all this kind of stuff. You can define geometries using primitive elements like points and lines and triangles. But for this use case, none of that is particularly relevant. So what I found to be the most useful is there's an SCN shape class, and this allows you to just take a 2D UI Bezier path, which it's a familiar UIKit construct, and you can use that to create a 3D geometry in the shape of the Bezier path. So like in this case, we're just using a rectangle for the view to represent the frame of a view. And optionally, you can like extrude it and give it some depth, but that's not particularly relevant here. And then there's the text nodes, where it kind of gives you some configurability over styled text like NS attributed string, only it's not quite as powerful as NS attributed string. There's less attribute type supported. But compensating for that is the fact that you can do all kinds of interesting styles with this. You can add shadows and depth, and you can pretty much make it look like word art from like Windows, like Microsoft Office, whatever, as you see in that picture. The second node type is the lighting nodes. So just to talk a bit more generally about lighting, the geometry is just the shape itself. It's basically like the mesh, like the frame of the shape. The way that it actually looks is determined by how it's shaded. So for example, if you imagine like a shape in like a cube shape, and you wanted to, figure out what it actually looks like, you'd have to assign materials to each of the faces. So the materials control what the shading of the actual sides are. So you can shade it using a color or a texture, which is like an image, or anything. And these materials change in response to various kinds of lighting. So depending on like what your lighting sources are, depending on the camera angle, the materials will look different. And so you can represent pretty complicated lighting setups using something like this, but the simplest one to use is something called diffuse shading. So the official definition of this is kind of wordy. It just says it's like the amount and color of light reflected equally in all directions from each point on the material surface. which is just a really long way of saying that this is just the base color or texture. So it's pretty much akin to, like, if you're familiar with setting CA layer.contents on a layer, like setting it to an image or a color or anything like that. That's pretty much the same thing here. So if you just want like that base texture, all you need to do is set the diffuse property, and you don't need like any special lighting nodes, because in this case we're not concerned with changing the appearance of the shapes as you move the camera. Like no matter where the camera is, the coloring or the shading is going to be the same. And so there's no special lighting nodes. You just use the diffuse shading, and that's pretty much it. Something I was really pleasantly surprised by here was how easy it was to get the camera stuff working. So normally with any kind of interactive scene type thing, you want these basic multi-touch gestures. So you want to be able to rotate and pan and zoom things. And if you were to implement this yourself, it would be rather complicated, right? Like you'd have to intercept the touch events, and then you'd have to figure out how to translate those into 3D coordinate space transformations and move around the camera and all of that stuff. And there's a bunch of math involved there that you probably don't want to be doing for this common set of functionalities that most people would want. So Apple thought of this, and they just gave you a simple property that you can enable. You set allows camera control to true, and you get all of the basic multi-touch camera control for free. Now, if you want to do something more complicated, like pointing the camera at a specific angle in the scene, then you need to mess with camera nodes, and you have to do some math, and that gets more complicated. But for this use case, this is all I had to do, and it just worked. So based on what we just covered, like it doesn't seem like there's, it's not that complex to start using, but there are a few things that I found that were particularly confusing when I started using it. When I started building, I could put together a scene of various layers and it would render and stuff, but there were these weird like rendering bugs that I couldn't figure out how to fix until I researched into some of the things that I'm going to talk about here. So one of them is the coordinate system. So I immediately noticed that the frames of some of these views that I was rendering were not appearing in the right place. And the reason for that is the ever confusing saga of how Apple does coordinate systems. So on UIKit, you have the bottom or top left origin, where as you go down visually, the y coordinates increase. And in core graphics, you have it the other way around, where the origin is on the bottom left. And on macOS, it uses that core graphics coordinate system, and on iOS, UIKit flips it. And so when you're using SceneKit, you have a couple complications here. So the first one is that compared to UIKit, again, you have the flipped y-coordinate issue. So the y, as you move upwards visually, the y-coordinates increase. Then you also have the addition of a third axis, which is the z-axis that you use to represent depth here. So like any kind of points that you're working with will, of course, have three. They'll have three coordinates to them instead of just the two x and y. And speaking of the z-axis, so in UIKit, when we have overlapping views, the ordering of the subviews is defined. Like for example, if you have a container view, you add a subview and then you add another subview on top. If those two overlap, like the one that you added after will strictly be on top of the one on the bottom. So in that way, like the subview ordering is deterministic, and the way you see it, it mirrors the order in which you added the subviews. In SceneKit, this is a bit more confusing. So for example, if you have two nodes where the z coordinate is the same, like let's say they're both at z equals 0, the system doesn't actually know which one is on top. The renderer doesn't know which one's on top. So when you go around and start panning the camera as it re-renders on every tick, it'll start kind of alternating which one is on top, and you'll get this weird flickering effect. And this is one of the ones that I found most confusing to debug when I built this. So what you end up seeing is something like this, where I have this text node with the class name and the blue background behind it on the same z coordinate. And so when I'm moving around the camera, like it keeps flickering in and out. And it was happening for like all of my content. So even the view snapshots, this was happening. So I figured like it might be a performance issue or something. Like maybe it's not, there's some like setting I can change to like amp up the rendering quality or something, and it would just fix it. But it turns out this is caused by what's called z-fighting, and it's a well-known thing in 3D graphics programming. So the fix here is like surprisingly low tech. So what you do is you add a really small z offset. So to the one that's supposed to appear on the top, you can add like a really small amount, like a 0.5, and that's not visually noticeable. Like it'll still appear like it's directly on top of the other thing. but that makes the Z ordering deterministic. So the system always knows which one's actually in front. And so when you move the camera around, you'll end up seeing it behave like it should. So you see there's no flickering here. Everything looks pretty nice. And I applied that across the thing. So like if there's a bunch of situations here, for example, when drawing the borders around the elements where a lot of things are at the same Z, but I had to offset all of those things by like a 0.5 to make it not flicker around when I was moving the tree. The second thing is that the materials, so like recap, that's like the shading that you use. In this case, this is like the image that's being rendered, the snapshot image. Only the front face of that's going to be rendered. And that's by default. So if you rotate around to the back, you won't really see anything rendered there. And depending on what you want, like this might be more of like a UI decision, product decision. This might make sense, but when I was playing around with it, like intuitively, it didn't feel like it made any sense. So I'll demonstrate here. So in this case, I'm rotating around, and then you go to the back, and it's white. That's kind of weird. I want to see that red color on the back as well. And it turns out this is fairly simple to fix. So for each material, you just set the is double-sided property. It's like very literal, which was surprising. You set that to true, and it'll do what you expect. Like the cost here is just like you're paying for the extra render cost of having to redraw it on the backside. But I mean, it behaves the way you would expect. So go back here, and it's red on the back. And so this is how I have it set up in the app. So besides like the things that are just confusing to understand, there are some things that are harder than they should be. Some common things that you might be used to in UIKit are a bit harder in SceneKit. So the main example that comes to mind here is drawing a border. So in the debugger, we draw these like blue borders to show you where like the frame of each individual view is. And so if you were doing this in UIKit, you probably just you set the border width of the layer, set the border color, all that stuff, and it just works, right? So in this case, there's no simple property that you can set to draw a border. You have to get the bounding box of the node that you're drawing around. You have to draw 4 line segments or more, depending on whether you want like a 3D border or a 2D one, which is a 2D one in this case. So drawing 4 line segments, creating a node, adding the 4 lines as child nodes, setting up the materials, geometries, all of that. So this is a bunch of like boilerplate that you need to write for doing a border. So like it's cool because SceneKit lets you render all of these crazy 3D shapes and stuff with like 2 lines of code, but then you go to like implement a border and it's like all this stuff. So this kind of thing is a little bit unexpected, but overall, once you figure out the right APIs to use here, it ends up being fairly simple. So in summary, yeah, if you know how to use UIKit, you can use SceneKit. There's no problem. There's not that much you have to learn, just like understanding the coordinate system, understanding a little bit about lighting and how materials work is enough to get you started. You don't need to really learn like any shader programming or anything to get started with SceneKit. That's definitely doable for more advanced use cases, but the basic stuff is very readily usable and it's pretty developer friendly. So moving on from SceneKit, the other topic that I wanted to talk a bit about was the view snapshotting system. So as of iOS 7, I think, this function is like the recommended way of rendering a view hierarchy into a graphics context. So you create a context, you call draw hierarchy, end context, and grab the image. Seems pretty simple, but there's a few gotchas that I ran into when I was building this. So the first one is the subview situation. And so this is like the intended behavior of this API, is that if you call this method on a view, it'll draw itself and all of its subviews into that context. The problem is that that doesn't really work for this use case because we want all of those subviews to be represented as individual layers, separated on the z-axis to show that depth. And so the solution here is, it's fairly simple. When you get to a view like that, you hide all of its subviews, then you take the snapshot, and then you unhide and restore the state that it was, the same state that it was in before. And then you do this recursively for the whole view tree. And then you end up with like individual snapshots for each view that don't contain its subviews. So I mean, hiding and unhiding views is kind of expensive. So this is like not ideal, but given that it's like a debugging tool and not something that's intended to like run in production as part of your app, it's probably okay. The second thing that was interesting with snapshotting was like the handling of visual effect views. So if you snapshot a visual effect view, and just to be clear, the visual effect views are the views that render like blur effects and stuff. So like UI navigation bars all have a visual effect view underneath them to render the blur. And so if you try to snapshot these things directly, what you'll get is just like a black rectangle. Like it's not going to render anything. And it turns out this is explicitly called out in the documentation. So Apple says that if you try to take a snapshot of a UI visual effect view, it doesn't work. You have to snapshot the whole window or the whole screen. And the reason for that is like, there's some complex compositing involved with rendering a blur. It has to capture all of the stuff underneath it. It's not just the one view and its subviews. So we can't just snapshot these the normal ways. There's a special case for handling this. So the constraint here is that to snapshot a visual effect view, it needs to be actually visible at the time that you take the snapshot. So you have to be able to snapshot the window, and you have to be able to see the visual effect view directly so you can crop it out. And so what we do here is we traverse the view tree, and then for each visual effect view, just go and hide all of the views that are on top of it. So you traverse through these individual subtrees, figure out which ones are on top, and then you hide them. And then once you've hidden them, you can take a snapshot of the whole UI window, and then from there you just crop the section of the snapshot that contains your visual effect view, and that's your snapshot. And when I was doing this, I found that Xcode actually appears to use the same approach, because if you go to Xcode and you capture view hierarchy on something that has a navigation bar, you'll actually see that in your app, when the simulator or when the program is paused, the navigation bar stuff will disappear, and you'll just see like just the visual effect view. And I have some screenshots here that demonstrate this. So on this sample app, the leftmost state is what it's supposed to look like. You can notice that when you do the snapshotting, and this is a screenshot captured from the simulator when I was doing this in Xcode, you'll note that it hides like the UI navigation bar, like the white background and like the buttons and the title. And then what you're left with is just the visual effect view. And so when you have this, you can just take a snapshot of the whole window and crop that section out, and then that's your visual effect view snapshot. So that accurately captures like the blended content underneath the visual effect view. So yeah, once that was figured out, like this works for all visual effect views, and it represents them pretty nicely in the debugger. So the final topic here is building Swift frameworks that work for both Swift and Objective-C apps. So if you're building an Objective-C framework, it's fairly straightforward. Pretty much every feature that you use in Objective-C will just work in Swift. There's a few notable exceptions, one of them being that if your Objective-C code throws exceptions, you can't capture those in Swift, so you have to have like an Objective-C wrapper over it that you call in Swift. But in general, most of the language features they bridge across to Swift very nicely. You might add like nullability annotations or some generics to make the API a bit cleaner, but overall, it's pretty straightforward. Doing it the other way around requires some explicit thinking about how you actually want to expose the API to Objective-C. And so I'm going to talk about what I found there, and I think the lesson's pretty simple. So you just put the add Objective-C annotation on pretty much everything. So you can't just put it on one thing, you got to put it on all your methods, your properties, and pretty much every piece of the API that you're exposing to the public, exposing to framework consumers. So just to illustrate here, I have these classes that are part of my public API in Swift, and like one of them is the configuration type that lets you configure various behaviors of how the snapshot view works. And the other one is like the public API for presenting the view debugger. And in both of these cases, you'll note that I didn't just put add Objective-C on the class, because that doesn't work. You have to go through and put the annotation on every single property and method. So what happens is if you just put the annotation on the class, you'll get the class available in Objective-C land, but it won't have any methods defined on it, and it won't have any properties defined on it. So you just get the class and nothing else. And then so you have to go through and just add all of these, and then you get your exported methods and your exported properties. So yeah, this is basically what I was talking about. It's not inherited, so you have to add these explicitly everywhere. The second thing is that you can't apply these to structs and enums. So if you're using Swift-specific language features like structs and enums, you can't usually just apply the annotation. It'll just error out on the compiler. So you're restricted to using Objective-C only constructs on your public API. So you can still use Swift language features internal to your framework. So you can, if for things that are not exposed in the API, you can still use generics and structs and whatever you want. But explicitly for the stuff that you're exposing, kind of got to constrain yourself. And besides just those, the optional primitive situation is also interesting because technically you could represent an optional bool or an optional int as an NS number because it can be nil and it can also be like a boxed value. But they don't do this bridging automatically. I'm guessing there's a good reason for it, probably because you don't want to get like certain numeric types mixed up, you know, like specifying a float and having it truncated in a weird way when you convert it to an integer. So you have to explicitly use NS number for these APIs for it to bridge correctly to Objective-C. If you use the optional types, it'll just fail to compile. And the other thing is that default parameter values are ignored. So Swift has a really nice feature where you can specify default arguments for a function so that if you can call the function without those arguments and it'll use the default values automatically. This feature is not supported at all in Objective-C. Just to illustrate what I mean by defaults, it's just like the configuration equals nil and completion equals nil. So this means you can call the present for window function with just a window parameter and exclude the other two, and it'll work in Swift. But these are just ignored in Objective-C. So whatever you export that has default values, they'll just export a method signature that has all of the parameters in it. And even if you like pass nil or something for one of the parameters, it's not going to use your default. So the defaults will only work in Swift, but it won't actually give you like a compiler error or anything about it. And finally, in Objective-C, we have this pattern of prefixing class names with like a 2, 3, 4-letter prefix. And we do this because Objective-C classes exist in like a global namespace in the Objective-C runtime. And so you have this danger where if you like use unprefixed class names, potentially you'll have some other library in your app that might be using a class of the same name, and then you get a runtime collision. Swift solves this by automatically namespacing their classes with the modules. But if you're exporting like a Swift class to Objective-C, by default it'll just use the Swift class name, which could potentially be dangerous. So you can add this annotation along with a custom name for the class where you can add your prefix or whatever, and you can just export it that way to Objective-C. Another thing that I found was how confusing it is to do the imports. I was reading the Apple documentation, and what they recommend is instead of doing it the normal way, like you would do like import framework name / framework name.h, you can't do this for a framework that's written in Swift. So they tell you to import the -swift.h header in your Objective-C app, which contains like the generated Swift definitions for those APIs. But I find this not ideal because you shouldn't have to worry about the implementation detail of whether a framework is written in Objective-C or Swift to know how to import it in an Objective-C app. Like that shouldn't matter as the consumer of the framework. So what I found is that like the not very commonly used, apparently, import directive that they added to Objective-C at some point solves this. So as long as you have module maps enabled for your framework, this style of import declaration will just work regardless of whether it's an Objective-C framework or a Swift framework. So I recommend like putting the second variant in your documentation because that first one is just weird. The first one is useful for something else though, which is that you can check the generated API of your Swift framework. So it works the same way as like command control clicking into another import. You can see the generated content. So if you scroll through a bunch of like the generated type defs and macros and stuff like that, you eventually get to the point where you see the definitions for your Swift, the Objective-C equivalents of your Swift API. And this is useful to verify because there's been a few times where I thought I exported things correctly on the Swift side, and then I went to use it from Objective-C, and some method or property that I wanted to use was actually not available. And so just like looking at this and doing a once over kind of helps verify that you've exported it in the right way to Objective-C. And finally, that's it. I'm open for questions. This is my contact information if you want to get in touch or if you want to ask questions like outside this event. Yeah, that's about it. Thanks, everyone.
All right, thank you so much, Indrajit. Raise your hands, please, if you do have questions. We do have a bit of time, and I'll pass the mic around so that people can hear your question in the video afterwards.
Were there any issues with performance at all? Like when the view hierarchy got complex enough that constantly snapshotting it and rendering it in SceneKit was causing it to slow down?
So the thing here is that there's no constant snapshotting. So it's not like a live snapshot where you're doing it on like every frame or every render of the view. You kind of just capture it at a given state of the hierarchy, and then that captures what you manipulate. So any like changes to the view hierarchy that happen after you capture aren't going to be reflected in the debugger. You have to go back and re-snapshot.
I may have missed this part, but what was the hardest aspect of building it out, like with the UI and everything?
Yeah, I think the hardest part of the whole thing was the thing that I covered with the Z fighting. I just built like the whole thing and it was rendering fine, and just, like every time I panned the camera around, it was just flickering like crazy, and I couldn't figure out what was going on. And I was like searching all these weird keywords like, oh, like SceneKit bad render performance, or like SceneKit interpolation or whatever, because it was causing like these weird rendering artifacts too. And it wasn't immediately obvious to me that what was happening was just that like they were taking turns overlapping each other. And so I had to like slow it down and figure out what was actually going on. And there was like, oh wait, there's something going on with the Z-axis. And so I searched up, I don't know, some keyword, and I found out about Z fighting, which apparently like every programmer who does 3D graphics apparently knew this. I didn't know it. But good to know.
Any other questions? All right.
Do you know if it's possible to capture the contents of UI view subclasses provided by other frameworks like, I don't know, MetalKit or even SceneKit itself? I know that often like SceneKit apps are not especially complex with respect to their view hierarchy, but have you tried that?
So the one that I know for sure that it works with is if you have an OpenGL view and you snapshot it, that does work. So I kind of assumed that like anything that's rendered with metal would probably work as well. So any kind of SceneKit or SpriteKit view probably does work, but I haven't tested it explicitly.
Cool, thanks.
Yeah.
All right. Thank you very much, Indraji.
Thank you.